So hello everyone, can you all hear me? Is my voice audible?
Yeah, look, we can hear you.
Yes, sir.
Okay, great. So first of all, welcome to our workshop on GenAI. Okay, so this session is going to be three series session because GenAI is very big. So today we are covering basic orientation, understanding of generative AI, and also what is large language model. In next session that I'm planning for next week, we'll be covering about roadmap of learning generative AI in 2024. Okay, that is the part of next weekend that I'm planning. So today we'll be understanding about generative AI. What is generative AI? Why are we talking about so much of generative AI? What is the idea behind that? And from where it came, what was earlier, what is the future, how does it looks like, and what is there for you in generative AI in large language models, what you can do. Okay. So I'll give my introduction. My name is Alok. I'm working as a senior data scientist in Darwin Box. It's an HR based IT company. Currently, I'm working on developing these large language model for certain applications of on our portal. So we are building GenAI models for different use cases like recruitment, talent management, employee engagement, and we are using the recent models that we are having for these use cases. Okay, so and so I'll just give you an overview of how these models work, what is the basic idea behind them, from where we got GenAI. So we'll start. So let us look at the agenda. What is our agenda for today? Okay, so today we are going to understand what is artificial intelligence, what is machine learning, what is deep learning, what is NLP. We'll talk little bit about computer vision, and the main focus, as I said, you is going to be on generative AI. We'll also discuss about large language models, and again we'll do some hands-on. Everybody, like, I have a lab for you that I will be giving you, where we'll actually use Gen AI to create some images. Okay, we are going to run and we are going to give some text and we'll create image, whatever we want. So we'll do that hands-on also. So this is the agenda that I'm planning for today. Okay. Okay. So first of all, let us understand what is artificial intelligence. Okay, we keep on hearing about AI, that AI is the big thing, but what exactly is artificial intelligence? So if you try to understand artificial intelligence, it is nothing but making machines understand the human intelligence, making them making them have the cognitive skill set that we human beings are having. If I ask you a question, what is it that machines have we human beings have, machines don't have those kind of expertise right now. Okay, so there are going to be two major areas here. One is the language capabilities. Okay, we are able to communicate, we are able to understand. Machines don't are not able to understand that right now. They're still working on that. The second thing is computer vision. Okay, again, this area is again, lot of development is happening around that, but there is a lot of scope of development. So basically, if you notice, slowly we have started talking to our devices, to our gadgets. If you look around you, you can talk to your mobile phone. You can say, "Hey Siri," or maybe Google Home, Alexa. You can Your devices are becoming smarter day by day. So you want to switch on AC, switch off AC, maybe turn off TV. You are having certain speech or text, let's say voice-based services there, which we are using that. So what is artificial intelligence? It's nothing but no, we are trying to simulate the human intelligence. We are trying to give it the cognitive abilities that we are having, making more and more like human beings. Okay, because still they don't have those cognitive skills. Okay, they are very smart, it can process a lot of information, no doubt in that, but when we look from the humanistic point of view, it is lacking the uh, cognitive skills. So basically, what are the applications of AI? Okay, application is everywhere. If I ask you any application that you have used in artificial intelligence, you may think of chat gpt or maybe using bard, but that is not the only application. If you look around you, your day in and day out, we are living in the world of AI. Okay, if you're using gmail, how does it know this is spam, this is not spam? It's an AI. If you're booking a food online, Swiggy or Zomato, how does it know how much time it will take? Again, it's using an AI. It's being some sort of clustering there. So if you're ordering, if you're trying to book a cab, like Uber or maybe Ola. Again, how does it knows, how much of what is the total duration, what is the total price that is there. So a lot of AI is there. Every day when we are searching something, we are using artificial intelligence. So we are already consuming so much of AI now. And so if you look at some of the use cases, okay, whether it is like banking sector, or fraudulent transactions, loan applications, approval and all. Okay, if you look at driverless car, that is another application where we are trying to look into autonomous driving and all. Then we are having computer vision. Okay, where if you remember the COVID cases where we were short of health professionals, they were not able to detect. So we can build an AI application that can solve this problem. And again, one of the major area concern for any company is the customer support. They cannot serve 24/7 because if you look at the backend team, it is having time like 9 to 5. That too 5 days working. If it is working for 5 days or 6 days. So again, AI can play a very important role. We can have a bots which can talk very similar to human beings. If you have that skill based, APIs and all, and then it can solve most of the problem. So it could be very helpful for the customers. Now, what is machine learning? Basically, we understood AI. So machine learning is the backend part where we are doing a lot of coding. So the application part that we look around it. Okay, the application is the AI part where you either look into the computer vision or you look into the uh, natural language processing. Okay, Uh, but the coding part where you're building the model, you're training the algorithms, and all those things is a part of machine learning. Okay, so where actually we try to train a model to make some sort of predictions. Okay, some of the examples would again be like spam filtering, recommending some products. You all might have experienced when you're trying to buy something online, Amazon, Flipkart. They tell you that people who bought this also, if you buy the other item, you will get some more discount there. Okay, this kind of recommendations keep on coming. Then we are having a fraud detection. Fraud detection, mostly if you're doing some transaction online, you might have seen sometimes you immediately get a call from a bank. They keep on asking whether the transaction was fraudulent or not. You press 0 or 1. So again, it's based on certain pattern. So it's based on certain pattern and it is identifying that. So medical diagnostics is other very important area where it can play a very important role, and a lot of things are happening around that. I'll just give you, okay, I'll give you some example in some time. Okay. But if you look at most of the countries in Africa and all, even in India, remote places, we don't have proper medical facilities. Okay, imagine if somebody is taking up a mobile phone and he's trying to share the symptoms, and immediately he tries to get some sort of recommendation. Maybe you visit certain doctor, or maybe certain precautionary measurement has to be taken. As again, COVID cases are coming up again, so what can be done here? Other thing could be the image recognition. So all these are applications of machine learning that we are having right now. Okay. Then we have something called as deep learning. What is deep learning? It's again a subset of AI where we are trying to use the neural network. Okay. So it's a modification of what we are doing earlier by using traditional models like supervised, unsupervised learning. But here we are trying to use a mechanism of the way our brain is working. So if you look at your brain, we are having neurons. Okay, so nervous system is made up of neurons. So if you try to replicate the same way here, build something very similar to that, very same mechanism. Okay, so we where we are having some input data coming, it is going to certain hidden layers and it is creating some output layer. So these are all a part of deep learning. Okay, so the lot of layers are there, and again, the application part, we are having very good models like convolution neural network for image processing. For NLP and all, we are having good libraries like RNN and LSTM. Then we are having some other spacey library. Those are very good. Even NLTK basic libraries are very good for NLP. Machine translation, again, how do you translate? Like the transformer models are very good at machine translator where you are having encoder decoder mechanisms. So if something is coming as an input, it can convert that into a form. So think of the application like I'm talking in my native language. I want to talk to somebody in France, maybe in French. I just keep on speaking my native language. The person, he speaks his own language, and real time the translation happens. And again, he's talking in French, I'm talking English, and we both are understanding at the same time. It's quite possible because nowadays we have a lot of these language capabilities, and it could be done very easily. So you may have a lot of these applications coming up. Driverless car, you all know that a lot of work have been done around that. The only part it's very critical because of 5G technology. Because if there is some latency, imagine if a pedestrian is crossing a road and the model is not able to find out, it will go and bump, maybe an accident, life is lost. So it's very critical, and that is why there should not be any delay. So a lot of testing has to be done. But anyway, it's again, a lot of work is going around that. Okay, so when we look at natural when we look at basically deep learning, it's based on the neural network that I'm talking about. So it's all the neurons that we are having in our brain, which are all interconnected. Some sort of information is passing through them, and then a lot of complicated processes are happening around that. Same thing we are trying to replicate. And some of the algorithms that you might have learned, or some of you might be aware of, is like convolution neural network, which is basically very good for image processing. Then we are having RNN, which are very good for sequential data like time series, sentences, and text. A modification of that is LSTM. Okay, just to prevent the vanishing gradients that we are having. Okay, so the LSTM models are good. Okay, so these are the models that we are having, the base models. Okay, and when we look at NLP, as I initially discussed that, we discuss about what is AI, then we discuss about machine learning, we discuss about deep learning, we discuss about. I think there is a lot of noise. So we discuss about machine learning, and basically when we look at NLP, so it's nothing but how do you actually make the machines understand the languages. A human language is very complicated. It's very complicated. So how do you make, if I say okay, like again the pitch and tone plays a very important role here. Okay, so if I say okay, see now this soft, or say okay, I mean this is agree. So just the word okay will not make a sense because What is the pitch of the tone? That also plays a very important role. So language, it is very, very complicated here. And how do you make machines understand that? If I say river bed, okay, so a river bed is like, you're talking about a river, or it like I'm talking about a bed. It could be a river bed, or it could be the bed at home that we are having. Same way we can talk about Apple as an organization, or maybe Apple as an, a fruit that we are having. So single word may not give you that understanding. So how do we how do we make machines understand this thing? Is again very, very complicated. Now, if you look at some of the applications of NLP where we can use them in text analytics to summarize the data, to write, some sort of finding out some sort of entities in the data for sentiment analysis. Sentiment is very, very important because the entire market is dependent upon the sentiment. Look at, stock market. If sentiment is positive, it will go up. If sentiment is negative, market sentiment negative, stock will go down. Then speech recognition. If you have seen some of the examples where like on Amazon or Netflix, it is identifying who is speaking. Like it is telling you the actors there whose voice is coming. So again, identifying that languages, chatbots, we talk about that. So NLP is very, very important. There are some applications like text summarization, classification, question answering, building a bot, sentiment analysis, identifying the NERs. Okay, a lot of other applications that we are having. The second important thing is the computer vision. So computer vision is basically where we are trying to deal, with the interaction between the computers and the real world that we are having. So we make them understand the images and then process the images or videos that we are having. So what is the application of that? It could be image classification, object detection, scene understanding, image segmentation, pose estimation. So example is like, let's say a driver, somebody is driving on the highway and he's feeling like he's feeling sleepy, and suddenly he sleeps. What happens? It's an accident. So can we build a model which identifies the pose, and if somebody is feeling sleepy, immediately there is a, some sort of signal, or there is some sort of warning that come up, and the person is, he just wakes up. Or there might be some sort of scene understanding, like traffic management. If you see, if the road is going to be blocked, and a lot of pedestrians are there, they're not able to cross the road. So maybe the signals could be managed. Or again, managing the rights and all. We keep on hearing about the drones that have been used by army and all to detect the terrorists and all. So a lot of applications we are having in computer vision also. Okay, that is coming up. Now we discuss about what is AI. We discuss about deep learning. We discuss about NLP. We discuss about computer vision. Now let us understand the generative AI. Okay, what is generative AI? Why we're talking about that? So there are two types of AI. One, so basically in generative AI that we are talking, what we are trying to do, we are trying to generate something new. Okay, or it could be a discriminative AI where we have all those traditional models. Generative AI is very special. Why it is special is that because here we are able to create something new, totally new content, something that doesn't exist earlier. It could be any image that you want to create, it could be certain text that you want to create, you want to write certain code, or there is some synthetic data. There's a report from Gartner that is telling that by 2026, 10% of the data that would be generated by GenAI models. Okay, right now we are hardly using 1% of it. So one of the biggest problem that most of you, if you've run ML model, you have seen is having a proper data for the model training. Okay, so GenAI can play a very, very important role here to create those kind of data for training the models. And these generative AI applications, they are basically built on top of large language models, which we'll try to understand. And there are certain foundation models, which are, foundation, and uh, models are built on top of those. A lot of training has been happened. Okay, so basically, if you look at, Gen AI, what is Gen AI? So basically, Gen AI is like, you can take examples like you are having a friend, who is watching a lot of movies, or who is reading a lot of novels. And after that, he comes up with his own idea. Oh, I can create certain movies like this, or maybe I can write certain novels like this. Same way happen here also. These models basically there are certain basic foundation models. They've been trained on huge corpus of data. When I say corpus of data, it could be encyclopedia data, Wikipedia data, whatever data is available online. It has been trained on that huge corpus of data to create certain to first learn the pattern from that data, and then to create something new, certain new data. So again, if you see the images here that I've put, these are the images created by a tool called as Mid Journey. So Mid Journey is giving very good image, and there is something unreal, again another portal which has come up, and it looks so natural, these images that we are having. So what is JDI? Basically JDI is nothing but it's a type of AI that's creating a new content. When I say new content, it could be a text. You want to write something, you want to create an email, or you want to write a summary of anything, or you want to write a story, anything that you want to do in terms of text, you can do that. Or you want to find out certain NERs, custom NERs, you can do it very easily. Or you want to create certain images, like normally in Photoshop and all, we try to edit images. We can do very easily using the GenAI here. Okay. Then we can create a new music. Like if you look at music, it's uh, mostly if we are trying to use music, we have to pay certain royalty for that. But here, by using generative AI, we can create our own music, whatever. It's totally royalty free music. And we can create a code, we can write the script that using generative AI. So how does it work? As I said you, it's initially been trained on huge corpus of data, and then it learns the pattern, and then it's trying to make the prediction. So it's using historical data to train and make some sort of predictions. Okay. Again, we discuss about the applications. Okay, where we are trying to create a new, like either it is in terms of art, in terms of music, in terms of certain languages that we are having. So we can do a lot of stuff here, and there's a huge potential. If you look around you, organizations are actually looking for something very new, and because of that, GenAI can actually create something new in terms of, not only in terms of art, music. I'll give you another example. A new antibiotics have been discovered. Now, this was not earlier. So let me share that with you right now. So what has happened is that we have discovered a new antibiotics, and it is done because of it has been done because of AI. Okay, I just share that. I'll share the article with you. So if I show you a new antibiotic by using they discovered this new antibiotic, okay, by using generative AI only. So a new class of antibiotics. So till like 1950s, it was thought that most of the discovery has been done. Okay, and they have been able to come up. But this antibiotic that we are having mostly is discovered by GenAI. So let me just write here by AI. So if you see this again, this article, that it is telling that this is the first new antibiotics in the 60 years that we are developing. Imagine around 1950s and 60s, most of the discoveries has been done, and we couldn't discover a new antibiotic. Now again, using AI, we are actually trying. We have discovered this new antibiotic, which is game changer, for certain problem. Like that, there are a lot of other problems that we are having, and same way, we can discover, a lot of vaccines, maybe a lot of other things. So pharma industry, if you look around, maybe around 10-15 years from now, it will be dependent a lot on the generative AI. Okay? A lot of applications, because drug discovery itself is a very complex process. It takes around 12 to 15 years for different phases. Like we start with uh, certain three phases, and then we are having phase one, phase two, phase three, and phase four, till it goes to the marketing. So there is a lot of time that is actually invested in that unless a drug is having the safety and the efficacy. So to cut down that time, AI can play a very very important role. Again, it's just an application that I'm just sharing with you. Okay, so other problem that I discussed was data augmentation. Like how do you go and create? So a lot of data would be created. I'll give you one more example in terms of music. Okay, let us look at these. So this is one website. Okay, Sound Raw, where actually you can go and you can create certain totally royalty free music. Like here, if I let me just go to this website. Uh, you don't even have to. I'm not even registered on this website. So let's say you want to try it for free. You just go here. Okay. So you select the genre what you want. For example, you want hip hop, you want to have rock, jazz. What type of music do you want? Let's say I want to go with the rock music. Okay. You select this here, and further it can create a totally royalty free music for you. Again, you can do, see, it is generating the music. You can even give a prompt, basically a text, what kind of music you want, what kind of beats you want here, and basis of that it creates. Like here it is already created something. Like let's look, listen to this. So you can see the options here. We have different energies also. I want to put it as low, high, medium. Okay, depending upon uh, how do you want these things to be there. It is still creating, as you can see. It may take some time, but this is one example where you can create totally new music royalty free music that we are having. Same way when we talk about the videos. Okay, so we can create new videos using models that I will show you. So we have this platform called as this website called as Hugging Face. So basically, if you go to this website, Hugging Face, there are a lot of models. Okay, so certain models are proprietary models, like companies like OpenAI, again Google, they are having their own proprietary model. Okay, but there are certain companies which are giving us access to the open source model. So here in this website Hugging Face, if you go to the models, you will find a lot of these examples. Okay, like the image that you saw. Okay, so created, uh, you can listen to them. I will try to be able to listen to them. Listen everything music. So you can edit the music, you can add the pitch tone, whatever you want. You want to add a bass and all, you can do that. A lot of options are there, customizations are there. But again, you don't need to be a singer to create a song. Now because of Genia, you can do a lot of things. This is just an example that you see here. There's a lot of other options you can play around with that. So this is one application that you see here. I was talking about Hugging Face. Some of you. So there are so many models. Like if I click on this model part, which you see here, if I click on this, so it will show you different models. Like you can see here, certain models are doing text to image or image to video, image to text. Okay, certain models are working on computer vision, like object detection and video classification. A lot of other things are there. There are certain models which will be doing certain tasks in NLP, like text classification, token classification, question answering, and some are there for audio. Okay, so like example, if you want to create something, actually you can try here, like text to image, that we are having. So if I click on this text to image, so many models are there. You can try any of them. Like this open, I can take this model. Here only you can just go and you can write some prompt and you can so let's say I want to create maybe certain things. I want to create a city with road traffic, okay, and people. So I'm just trying to create something new with a lot of traffic around city and all. Same way you can do. So I've just written a prompt here, okay, and let's wait for it. Okay, so again, this is just one example I'm giving. There are a lot of other options that you all can try. Okay, I'll give you other example also. These models right now they're hosted on the Hugging Face website. So this is one example, like how do you go and you create a prompt, you just write and you do the testing here. But actually, if you want to deploy this model, to deploy this model, you will require infrastructure. It could be either your any of the cloud environments that we are having, whether it is AWS or Azure or any other environment, or it could be using on premises. It could be a container based services that we are deploying these models. But remember one thing, the size of this model is huge. Okay, so they will consume a lot of storage resources as well as to run them. What will happen? It will consume a lot of GPUs. Okay, so that is a problem with large language model. There are a lot of solutions, around them using RAG and all. Those kind of things are there. And again, what I see that this again, these large language models are evolving. So there is a lot of research happening, and in future, maybe down the line, 6 months, 1 years, you will have a small models that you can still run on your local machines. Okay, ultimately, it's all about how do you carry the weight and bias of model that has been learning here. And let it get created, will come back. Okay, it may take some time. So okay, so same way, we can design a product. Think about a unique product that you want to design. Okay, and lot of features we are having. So we want to create certain marketing template for that. We want to create a product design. We can do that. Okay, and also JDI can play a very important role in research and development. Okay, we never know that so many things are there. So in terms of capabilities that we are having, creating certain text, like writing certain articles, poem, code, script, creating certain stories. A lot of YouTube content have been created using ChatGPT. People have been using these ChatGPT models to create that, writing the script, for the videos and all, which could be done very easily. uh, Realistic images, paintings and cartoons, you can create them using models like Mid Journey or maybe DALI model that we are having from OpenAI, and there are a lot of other models you can try. Audio, again, generating audio, we just saw example of creating certain music. You can even uh, uh, copy your own voice and you can create. Nowadays we keep on hearing about deep fake videos that we are having. So their entire audio and even the videos are replicating, they've been copied, and it creates so natural that we'll never know that this is created by GenAI models that we are having. Again, there are lot of tools that we can use for these kind of things. Okay, so certain models that we are having, as I tell you, DALI model is again from OpenAI, which creates certain realistic images. GPT-3 models, basically these are all transformer based models. Okay, I'll talk about what is transformer in some time. But these are all transformer based models. So they try to uh, do some sort of translation, create some content, and again jukebox is able to generate some music. The examples from OpenAI that we are having. So when we look at generative AI, now what is the mechanism behind that? So the techniques, that the foundation models that we are having are nothing but the models like RNN. Then we are having GAN models. Okay, and so there are different models, and basically the transformer architecture, is what is the foundation model for each of them. Now to understand what are these foundation models that we are having, again I'll discuss about these foundation models. But remember that generative AI, when we talk about that, so LLM is a subset of that. Basically, these large language models that we are using here, it has been trained and consumed on huge corpus of data, and what it is trying to do, it is trying to mimic the natural language processing that we are having. Okay, there are certain foundation models. The foundation models are basically these generative models, and then we are building using these transformer models. So there are basically three type of transformer model. One is only encoder, one is only decoder, and one is having both encoder and decoder. So let us understand these. I'll quickly move away. So to explain you the transformer models. So basically, transformer model is made up of two important components. One is called as encoder, one is called as decoder. So what happens in the encoder, like whatever information is coming from outside, okay, the encoder is trying to understand that, it is trying to create a vector, some sort of embedding vectors, and then it is passing. There is a lot of other mechanism happening here, and it converts into a certain form which decoder tries to understand, okay, and it is trying to understand and further convert it into a form that we understand. So initially what happens, let's take example of language translation. So you're trying to input certain data here, and you're trying to convert that to a French. So here input output, the relationship, like some sort of mapping that is happening is learned at this level. So what relation English had with French? No, those kind of mapping is learned by this architecture. And then when we bring some new data, it is using those previous mapping, those previous learning to translate here. Okay. It is like we play Damchara. So you call one person from the other team, give a name of the movie, whatever is there, and then he goes and he try to enact. The other person is trying to guess that. Exactly this is what encoder is doing, and decoder is trying to guess that based on the movie that this team might have earlier seen, or they might be aware of that. Imagine if they don't know, they cannot predict that. So this is how it happens. The transformer model is working on that. As I told you, there are different variants of that. Certain GenAI models are only having encoders. Okay, certain GenAI models will only have decoders, and certain will have both encoder and decoder models that we are having. The another very important mechanism that we have along with this encoder is the attention mechanism. So this paper was published around 2019 by Google team. So what they mention is that if you see, this is nothing but this is encoder and decoder architecture, but here they're also having attention mechanism. So attention is like when you're trying to create something or when you're trying to predict something, the focus should be on the very relevant information that you're having, not on the very distant information. Focus on a very specific part, very where you want to make the prediction, and then the output is good. So it was published around in 2018. Then we got the first model, BERT model, that is based on this, which was the primitive models for all these large language models. And on top of that, a lot of other things have been happened. Okay, so when we look at these LLMs, how do they make the predictions? So initially, for these large language models, what we have to do, we have to write certain text. The input text is what they understand, and they try to make the prediction. So these text that we are typing to these large language models, we call them as prompt. Okay, so one way you want to do certain task, you just write a text and generate an output. So we call it a zero shot learning or zero inference. But if I give one example in that, say like I want to do a classification, and then I give one example that okay, this is the label, or you want to do a sentiment analysis, and then you say okay, give me a sentiment of this. So this sentiment is positive, give me a sentiment of this. So what you're doing here, you're giving one example, and then you're asking. So this is called as one shot learning. Like that, if you give two example, it becomes two shot learning, three shot learning. So if you look at these chat GPT models and all, ideally they are having 4 to 5 shot learnings, that we are trying to make a predictions. Sometimes we also have this in context learning. So if you look at this example, we already give both positive negative review, and then we say okay, tell me what is the sentiment of this. Okay, so we are giving both the context here again. So this prompt is very important, okay, which I'll cover. I'll just keep this part not required, but I'll come to the large language part here. So the prompt that we are writing is basically going to large language models. So what are these large language models basically? So these large language models that we are having, these are nothing but these are the foundation models. These are being trained on huge corpus of data like text, images, speech, structured data, and lot of other things, codes and all, codes from the GitHub. Lot of it has been trained on a lot of corpus of data, and then because of that, it can do task of generating a new text. Like it's actually working in NLU and NLG, so it can do question answer, it can do sentiment, and a lot of other stuffs. Okay, so how does it works? Basically, it is using the memory, like whatever learning has happened, whatever weight and biases it has learned, those have been stored, and finally it can use that to make certain predictions here, certain some sort of predictions. And if you look at the journey of these large language models, okay, so as I said, the transformer architecture initially LSTM model was there, which was performing good to a certain extent, but not very natural text. Then 2017 is where these transformer architectures was proposed, that is having that encoder decoder, and 2018 somewhere we got that attention mechanism. Then we got this BERT model and all. 2020 is where the first GPT-3 model was, you know, introduced, and you can see it is. So it was not going doing very good. 3.5 is where we use unsupervised learning, and a lot of training happen further, and it is able to create very good output. We are having GPT-4. GPT 4.5 is coming, okay, and GPT-5 is where they are telling this is going to have a superhuman intelligence. A lot of applications is going to be beyond the human capabilities. So we're just waiting for that. Again, coming back to these, some of the very good models that we are having. So you can see, like Roberta model, Bard model, and again T5. So these models are used for text summarization or maybe using some sort of custom NER predictions. Okay, we can use BERT for sentiment analysis. Again, these are primitive models. ChatGPT could be used for doing a lot of tasks. Okay, we can use ExcelNet for NER models. You want to do some sort of predictions. So even there are a lot of companies, that main companies that are working on that. I will talk about that. But before going that, remember one thing: all these large language models that we saw the previous slide, they've been trained on huge corpus of data. Okay, and the learning, whatever uh, the learning has happened, we measure them by using parameters. Okay, so whatever weight and biases it has got, so the parameter is something that model is learned. Okay, for example, if you look at chat gpt, it is having around 175 billion parameter, whereas GPT-4 is having 1 trillion parameters. Nowadays, we have a lot of open source model also, like Llama 2 model, 7 billion, and then it is having 13 billion and so on. So it will keep on coming. A lot of these large language models will be evolving. Again, see, if you look at like the future of GenAI that we are talking about, so around 40% applications is going to have a conversation by 2024, next 2 years. I mean, this is 24 that we are having. So there's a lot of potential. In 2020, it was only 5%. So there would be a lot of requirement, okay, again, of people who are having knowledge of large language models, who are having knowledge of generative AI. Okay, a lot of websites, mobile applications by 26, 60% of them would be using generative AI to create the design, the template. Okay, and again, a lot of other applications. This I'm just got this data from Gartner. There are a lot of other modification, lot of applications that might be happening around that. So so which are the major companies, which are working on this field? You need to understand, because see, when we look at India, it's having a lot of labor pool, and we can see a lot of students. They want to learn AI, and this is the right time actually to learn a lot about Gen AI, because there is a lot of applications in the market. There will be need of the resources, the labor pool, people who can work on the Gen AI. So Gen AI is right now on fire. Next 5 years is going to be all about generative AI. Okay, the companies like Salesforce, app, they are building, like even Apple is building its own proprietary large language models. Okay, and if you look at major organizations like Google or AWS or IBM or even Microsoft, they already are having certain applications. For example, Google is having two models. One is Palm model, that is enterprise level multi-model for different tasks. Bard is what interface, a chat interface that we are having. So Google has come up with something called as Generative AI Studio, which is very good. You all can try that. So in Generative AI Studio, you can do a lot of testing. You can write certain prompt. You can do certain testing. Okay. Maybe I'll try to cover it in the third series that I'm planning. But today is just a high level overview of how it is working. Okay. So you can use Duet AI from Google in terms of using an AI assistant that is having the NLP capabilities. Okay, same way it is having Kodi that is supporting 20 languages for different programmings like Python, Java, JavaScript. That is, very, very good. Microsoft already has collaborated with OpenAI. Okay, so it is again using a lot of these OpenAI tools like ChatGPT 3.5. It is also having other text model like DaVinci models. Even 3.5, maybe 4 may come. They're not open to enterprise, but they will be opening up all these models also. And if you look at the other major company like Amazon, so Amazon is tie up with Hugging Face. We just saw that website Hugging Face, if you all remember. So again, it is providing a lot of those models on its platform. It is having a service called as AWS Bedrock, which is, again giving access if you want to try. They also are having their own GPUs and all. So the plans for Titan, which we can run and we can train the model on this. Okay. So before going, I'll just give you an example of. We'll do some hands-on here. So I have a notebook. This notebook I'll just explain you. So this is an Delhi model from OpenAI. So what we are going to do, we are not going to consume any GPU right now. We are not going to consume any of the paid services. This is totally free, and I'm going to run this for you right now. And I'm going to share this notebook with you. So let me just run it. So we'll try to create certain images. Okay. Uh, we'll try to create certain images and we'll see how it is working. So I'm just running this demo for you. So we are seeing how does this model works. So Delhi model is again for image creation. If you write a text, it can go and it can create an image for you. So I'm just downloading this library. Okay, this is done. So let us import this. So here we have a prompt, robots enjoying sunset in Paris. What if I say in Delhi? Okay, I'll just change here, or maybe in India. I don't know how it is going to, what it is going to create, but somebody has created some image earlier. I'm just going to change this and I'm going to run this and we'll say ocean. Okay, so it is downloading the model right now. It is running that model, initializing this thing. It may take little bit of time. So so here what we are doing, basically we are trying to run the model. Okay, and this model, what we'll do, we'll give a prompt here. Seed is basically for reproducing the code what you are doing, and grid size means I want to have a 2 by 2, like whatever output that we are creating, it should be 2 by 2. That's what we are telling here. So once it is done, then we'll try to create the image. Meanwhile, I can take some questions. Please let me know if you have any question. Or you can change the grid size. Grid size is basically, if you look at these image that we are having, 2 by 2. So if you want to change it, you want to make it 4 by 4, you can do that. Okay, the only thing is that it may take little bit time for that, but you can go and you can do that. Okay, so it is taking some time. It ideally doesn't take that much of time, but okay, we'll wait for it.
Hi, hello.
Yes.
Yep, thanks for this session. Okay. So, just need one information from your side. I am from the networking background. Okay. And then we are new into the programming. You can consider the programming, everything, everything we are new there in all the fields, something to AI, whatever the programming are there, prompt engineering. This is completely new for us. So, from where you want us to start so that we can learn this generative AI and
Yeah.
how this can help us into our day-to-day networking uh, operations.
Yeah. Okay. Thank you, Yogesh, for the question. So, what I'm planning in the second session that I am planning for next week on 14th of Jan is I'm going to discuss roadmap of generative AI. Like, if you want to, start in generative AI in 2024. So, what is the roadmap that we can cover here? So, maybe in the next session that is on 14th, you can join that. I'll discuss everything. How does the learning journey looks like, and what else we can do to learn this entire thing. Like you have to know at least one programming language. Basically, Python is the easiest language that you can learn. Then also there are certain basic foundation models that we need to know. So those models are very simple models, RNN, LSTM generative models that we are transformer models that we are having. Okay, so those models you need to understand, and then you need to understand this prompt engineering, basically how to create a prompt. What is the syntax of the prompt. So I'm planning of taking certain sessions. Okay, which will be coming next week and after that also. So please join that. You will get a lot of insight on that. So all of you can see, we've just created certain images, robots, sunset, and then see. What I want all of you to try this notebook right now, even if you don't, there is nothing to understand actually. It is just having the text, the seed, and the grid. That's it. So I'm putting this model here, just telling you, see how we can so easily we can go and we can create this kind of model. This is just one example of it. There are a lot of other examples that I will try to bring. Okay, the coming session that we might be having. So give me a minute. I'll share this. So I want all of you to go and okay, wait. So I'll upload this notebook here. There was some issue sharing this. So I want all of you to experiment on this, try on this, and see. Just play with this. It may take some time to upload these resources. Okay, just get hands on. But this is the right time to learn the generative AI. Okay, and as I said you, it is very very simple, very very easy. You just need to understand certain tools. Okay, maybe certain programming languages. Very easily we can learn Python and all. Hardly 15 hours you can cover Python. So I've also designed an entire curriculum, maybe that I will share in next session itself when I discuss about the roadmap. So if you really want to be part of this journey, what you can do, what are the things that you can learn, that I will be covering in the next workshop that I'm planning on 14th. So please join that. Okay. I've already shared the link in the chat. Can you all go and try that? See if that notebook is opening. Please run that. Okay. Meanwhile, I'll take some more questions if anybody is having. Okay, if you want to learn prompt engineering, very good. Prompt engineering is very, very simple. You need to understand, when we talk about prompt engineering, you have to give a certain context. Okay. Like example, we saw that zero shot learning, one shot learning. So maybe you can give one example, or maybe you can give in context learning. So there's a lot of things in the prompt engineering also. I'll try to cover it in the last session, third session that we might be having on the 21st Jan, more about the prompt engineering. So this is three series that I'm covering. Today was an overview of generative AI LLM. In the next session, I will discuss about the roadmap. And the last session that we have on 21st, I'll talk more about prompt engineering. What are the good practices? How do we create a proper prompt structure of that? And I will also discuss about some of the use cases that I'm doing, my team is doing, some of them are here. So what we try to create certain models, what we can do, like a lot of open source is also available. So how you can go, you can build a model using any of these tools that we have available. Okay. And most of the open tools itself are so good, like open source tools, you don't need to go for the paid version. The only problem would be the deployment part, because a lot of consumption would be required. But again, there are a lot of options which we can discuss in the coming sessions. Okay, there's one more question. I've got a project from a Bangladesh client, the company CEO. He want to build a GPT chatbot where can give mathematical problems and musical generation. You can connect with me there after this call, maybe on WhatsApp, and we can discuss about that. Okay, definitely. Chat GPT models, we can use it to create poetry. You can write, you can create a music, or certain mathematical. Also, we are having certain LLM which can do only they have been only trained for mathematical operations. Okay, we have these LLMs. We can discuss about that. Any other question, guys? Are you running the notebook that I've shared with you? Okay, so we have 1 minute to go. Please let me know if any question is there. I hope you all at least got an overview of what is generative AI, what is large language model. Okay, so every weekend I will be having one session. Please join that. Okay, I just want to spread the awareness of creating these. How do we actually learn generative AI and large language models? Okay,
Yep. Thanks, Alok.
okay, you're welcome. So thank you all. See you all next week. Bye. Good night.